Good morning, Year 11. Welcome to your next lesson. Today we're going to be hopefully looking at exact trigonometric values. So this will be recalling on your basic trig knowledge of manipulating cosine, sine and tangent. First thing I want you to do is pause the video for me and have a go at the 7 questions in front of you, working with surds and fractions. It's going to be massively important in this topic. So can you pause the video, please? You may need to go away and do a little bit of extra work first, but can you please simplify and rationalise those 7 questions? Okay, off you go. Okay, guys, right, let's have a look then. So, number 1 is to simplify. So, to simplify the surd, we need to find a square factor. So, for 45, I want to split this into root 9 times root 5. So I can have 3 root 5. Second one should be nice and easy because we can actually work out the square roots. Square root of 100 will be 10. Square root of 1 is 1. So we'll have an answer of 9. Again, root 9 times root 4. Again, we can work out the square roots. Always see if you can work out the square roots first. So we can do 3 times 2. So we will get an answer of 6. Divide in fractions. Keep, change and flip. So we've got to make sure we have a fraction first of all. So if you've got a whole number, you put your whole number over 1. We're going to change it to a multiply and we're going to split the second fraction. So we'll end up with 9 over 1 times 2 over 1. Gives us 18 over 1, which will be 18. To rationalise the denominator, we need to times top and bottom by root 2. Root 5 times root 2 will give us root 10. Root 2 times root 2 gives us root 4. Then we can simplify, we'll have root 10 over 2. Next one, again, rationalise the denominator. We only need to multiply top and bottom by root 2 again. So we will end up with root 10 when we do root 5 times root 2 over 3 root 2 times root 2 will give us 3 times root 4. Root 4 is 2, so 3 times 2. So we will end up with root 10 over 6. Last one, number 7, bit of a fraction to work with as well as the divide. So we'll do the same process as number 4. We change root 5 to root 5 over 1. We change to a multiply and we reciprocate our fraction. We can multiply across. We'll have 2 root 5 over root 3. We're never going to leave a fraction with a root as a denominator, so we need to rationalise. Times top and bottom by root 3 is going to give us 2. Root 15, root 3 times root 3 will give us root 9. Root 9 is 3. Quick recap on working with surds. If you are not confident on this, you will need to go back and have a quick look at those guys. Okay, exact trig values then. So the aim of this, there are exact answers, i.e. answers that can be written as surds or as fractions for the following. We need to work out sine 0, sine 30, sine 45, sine 60, sine 90. We need cos of those as well. And then we need tan 0, tan 30, tan 45 and tan 60 as well. Now these will be on a non-calculator paper. Okay, so these are just things you have to remember. Okay, now rather than remembering them, what I want us to be able to work with is we need to be able to derive these instead. And it all bases itself off 2 triangles. Okay, so this is where I need you to start making some notes. The first set that we can derive comes from using an equilateral triangle whose sides are 2 units. Now from this triangle we can derive sine, cosine and tangent of 60 and 30 degrees. If I have an equilateral triangle, each of 2 sides, I know my angles are all going to be 60 degrees. Okay, it's an equilateral triangle. Now, in order to use our basic trig functions, we have got to have a right angle triangle. So all I do is I drop down my perpendicular. Okay, that's made me into a right angle triangle with a 30-degree angle. We also need to think about what the base has become. Because it was equilateral and I dropped the perpendicular down, that's going to make each of those sides 1. And I can then start working out. So if I forget, okay, the rest of this triangle on this side. From here, I have now made myself a little right angle triangle. Okay, now from this, I can work out sine, cosine and tangent of 60 degrees. Okay, so if we think about sine, we know that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tangent is opposite over adjacent. So if I pick one of my angles first, so say I'm going to start with 60 degrees. If I need sine 60, I go for my angle and I need to find out what my opposite side. So that is this length here that currently we do not know. The second thing that we always need to remember when we use right angled triangles is Pythagoras. Okay, now we can use Pythagoras to find this missing length. Pythagoras, we square the sides first of all. So 1 squared gives me 1. 2 squared gives me 4. To find a missing side, I either need to add my squared values or subtract them. Because I'm finding a shorter side, I need to subtract them away. So I'll do 4 subtract 1 gives me 3, and a square root. So I end up with root 3. So back to sine 60 again. Opposite my angle is root 3. The hypotenuse is 2, so I can have sine 60 as root 3 over 2. Using that 60 degree angle, I can go opposite, I can have hypotenuse. I can then work out what cos 60 is. Using the same idea, so I know cos is adjacent over hypotenuse. Again, I base myself off 60. Adjacent is 1, hypotenuse is 2, so I end up with 1 over 2. Finally, I have tan 60. Tan, opposite over adjacent. My opposite is my root 3. My adjacent is 1, so I end up with root 3 over 1, which can just be written as root 3. And that's where my exact values for 60 come from. We do exactly the same idea with 30. So, sine 30. I'm now going to go up to my 30 degree angle at the top. So sine is opposite over hypotenuse. Opposite my 30 degree angle is my 1. Over my hypotenuse, which is going to be 2. So sine 30 will give me a half. I can then have cos 30. Cos is adjacent over hypotenuse. The adjacent is root 3. The hypotenuse is 2. So I can have cos 30 as root 3 over 2. And the last one, tan 30, becomes adjacent, which is root 3, opposite even, that's 1, over adjacent, that's root 3. So tan 30 becomes 1 over root 3, which we can simplify, can rationalise to root 3 over 3. Okay, but either of those will be absolutely perfect. So from that one triangle that we started as an equilateral triangle with sides of 2 units, we split down the perpendicular. We know that originally all our angles are 60. The one from the drop down the perpendicular gives me a 30 degree angle. Using Pythagoras, I can find that root 3, and then I can generate all 6 of those different values. Please make sure you have noted that down and you have an example of how you can derive these. Okay, please make sure you've got that noted down. Okay. There is another nice clear view of it if you just want to write that down, but we've gone through the process now. Okay, now we also need to be able to get the exact values for 45. Okay, now what we use to generate those, to derive those, is we're going to use an isosceles triangle whose sides are 1 unit. Okay, so it's a right angled isosceles triangle where we've got sides of 1 unit. So we're going to start with this. Again, because it's isosceles, okay, and we've got a right angled triangle, we know we have 2 angles of 45 degrees. Okay, and again, because we've got a right angled triangle, I can work out that missing hypotenuse just using Pythagoras. 1 squared is 1, 1 squared is 1. This time I'm finding my hypotenuse, so I need to add those values because it's a longer length. So I end up with 2 square root to find the length, so I'll have root 2 there. From this position, I am now able to find sine of 45, cos of 45, and tan of 45. So sine, we know sine was opposite over hypotenuse. Doesn't matter which angle I use because they're both 45. So we're going to focus down in this bottom left instead. So focusing down in the bottom left, we go opposite, which is 1, over my hypotenuse, which is root 2. So we will have 1 over root 2, which we can rationalise to root 2 over 2. Cos 45, we know cos comes from doing the adjacent over the hypotenuse. So I've got an adjacent of 1 over a hypotenuse of root 2. So again, we'll have 1 over root 2, which can be simplified to root 2 over 2. And finally, tan 45. Tan, we know, is opposite over adjacent. Opposite is 1, adjacent is 1. So tan 45 is 1 over 1, which will be 1. And that gives us our final 3 values that we need. Okay, so 2 triangles we need to remember can then generate 9 different exact values that we need for trigonometry. Okay, again, make sure you've got copies down of the triangle and how to derive it. A slightly neater version is on the screen for you now. Now with those, so we've got 9 of them we have to remember. Okay, now by all means, you can just remember them. Okay, however, it is much easier to remember just 2 triangles and how to derive them than it is trying to remember all of the different exact values. Okay, I certainly can't remember all of the values. I have to derive them each time. So if we learn instead how to derive them rather than how to memorise them, we will be in a much better shape. Okay, what I do want you to do, final 5 really simple ones for you that can all be generated from the graphs that we have looked at earlier. Because if we think about the graph of sine theta, hopefully remember sine looks like a wave and we go between 0 and 360. So hopefully we can find sine of 0 is 0, sine of 90 is 1. Okay, we've got cos theta, which looked like the bucket, which again went between 0 and 360. So we can find that cos 0 must be 1 and cos 90 must be 0. Tan, a little bit harder to remember. Okay, a little bit different. But again, remembering that between 0 and 360, what it looks like. So we can remember that tan 0 must be 0. Important to remember also tan 90. Okay, there was an asymptote at 90, so tan 90 does not exist. Okay, so that's 5 extra ones that really shouldn't be too difficult to remember at all. Okay, can just be generated from the graphs we did a couple of topics ago. Okay, right. What I now want you to do, using those parts, can you now pause? Can you now copy and complete the table for me? So pause the video now. Can you please copy and complete? Okay, guys. So that's what our completed table should hopefully look like. Hey, right. Once we have got to this point, the first thing I want us to do is just to be able to work with these exact values. So we're going to have a few lessons on this. We're going to have one where it's just working with them, remembering them and manipulating them. Then we'll do another where we apply it to actual triangles to find missing lengths. And then we'll have a third lesson just looking at the exam style questions that come from it. So the main thing I want to focus on today is looking at questions like the following. Okay, so we'll do things like sine 30 plus sine 60. Now this is where the starter was really important. You need to be comfortable working with surds and comfortable working with fractions. Okay, so if we need to do something like sine 30 plus sine 60, we need to know the exact trig values first. So sine 30 plus sine 60 will become a half, because that's sine 30, plus root 3 over 2, because that was sine 60, and we can add them together. This one's nice and easy. We've already got the same denominator, so all we'll go is 1 plus root 3 over 2, and we can leave it like that. We haven't got to rationalise our surd, haven't got to do any work like that. We can just leave it as it is. Another one, sine 45 minus tan 30. So sine 45 is root 2 over 2. Again, this is where it really helps if you've rationalised your exact values as well, because it's so much easier to work with a whole number as a denominator rather than a surd. Tan 30 gives us root 3 over 3. And we are subtracting them. So we've already got, oh, sorry, that was root 3 over 3, wasn't it? So we need a common denominator. Back to a bit of fractions work, back from year 9, I think it was. So we're going to need both parts over our common denominator of 6. So times the first one by 3, so we'll have 3 root 2. Times the second one by 2, so we'll have 2 root 3. So we end up with 3 root 2 minus 2 root 3 over 6. And that would be perfect. Right, I want you to pause the video again. Can you please have a go at those 3 in front of you? Have a go at answering them, and then we will go through the answers. Okay guys, let's have a look then. So, sine 30, nice simple one. We're going to have a half plus cos 45, which is going to be root 2 over 2. Nice simple one, this one. 1 plus root 2 over 2. Okay, sine 30 minus cos 30. Sine 30 will give us a half. Cos of 30 gives us root 3 over 2. So we'll have sine 30 minus cos 30, which is root 3 over 2. So again, we'll just go 1 minus root 3 over 2. Last one, tan 45 just gives us 1. Cos 60 is a half. Nice and simple. We need to make our whole number into a fraction. We need our common denominators. So we end up with a final answer of 3 over 2. All I want to focus on in today's lesson is 1, how we derive and find the exact values, and 2, just using the exact values in simple sums. We will bring triangles back in again next lesson. Okay guys, can you look on to show my homework for me for the worksheet that I have asked you to complete?